Hi, we're going to be going through the spring semester exam review. I'm going to be working through all the problems. I'm actually going to do the first couple of pages. A couple of the other teachers are going to do the rest of them. And this will allow you to get help on what you need help with from this semester. To begin, we have the conics. It's not chapter 11. It's chapter 10. Sections 2, 3, 4, and 5. So to begin, it says, write the equation in graphing form of a parabola that has the following conditions. So to begin, let's be reminded quickly about the equations for a vertical parabola. We have x minus h squared equals 4p times y minus k. We have the horizontal, that is y minus k squared, that's messy, equals 4p times the quantity x minus h. That's just in general. So for part A, we have a vertex at -1, 2, so we want to plot that point. And I'm going to call that V for vertex. And then the focus is at -1, 6. And label it F for focus. So automatically I know that this is going to open up. Remember that the parabola contains the vertex. It curves around the focus. The directrix line is behind it. So this is going to open up, which means it's vertical and it's opening up. Just make a few little notes. You know that we use the vertex is the HK, so we're going to be using those points. I circle them because that's going to go in my answer. The only other thing I need to know now that I know it's vertical, I know what H and K are, I need to know what P is. Well, P is the distance and direction from the vertex to the focus. So from the vertex to the focus, we're going up 1, 2, 3, 4. So that means that P equals 4. So to write our equation, we're going to have the vertical. So we have x minus, and so x minus a -1, which is x plus 1, equals 4 times p. Well, p is 4. 4 times 4 is 16, times the quantity y, and then minus the k value, which is a 2, and that is our equation. Next one, the focus is at 3, -4, and the directrix is at x equals 7. So we have a vertical line at 7. So if the vertex is contained in the parabola and it curves around the focus and the directrix line is behind it, then that means this is going to open to the left. So I know it is horizontal, and I just put my little arrow opening left. And where's the vertex located? Well, it is halfway between the focus and the directrix. So that coordinate would be at 5, -4. And so that's our H and K. I'm going to circle those because we're going to need that in our answer. And we also need to know what P is. Because it is opening left, then P is negative, and it's the distance and direction from the vertex to the focus. That's a -2. So we're ready to write our equation. The horizontal is y first, and it's minus k, so that's a plus 4 quantity squared equals -2 times the 4, because it's 4p, so that'd be a -8 times the quantity x minus the h, which is a -5. That's the equation of that parabola. So now if we move on, this parabola, if we look at the equation given, we need to determine some things because we have to graph all of these parts. So this one is horizontal because it is y squared. I know that the vertex, I'll just put a V, is HK, so that's going to be a 2, -2. Remember that H is with the X and K is with the Y. And the P value we're going to need to know, because 4P is -8, then P has to be -2. Because it's horizontal and negative p-value, that means we're going to be opening to the left. So I'm going to plot my 2, -2 point as my vertex. And if I go left 2, I'm going to get my focus. And if I go right 2, I get my directrix line. And remember, from the focus, I need the total focal width to be an absolute value of -8, which is +8. If I go half of that on either side, so if I go 4 on either side, then through the vertex and through the endpoints of the focal width, I draw my parabola opening left. That's it. For part B, this one, because the x is squared, it is vertical. The vertex is going to be located at HK. That's going to be a -3. Remember, H is with the x, K is with the y. It's always the opposite sign because of the minus in the equation. And the p-value, because 4p is 4, then p has to be 1. So I'm going to plot at -3, -1. That's my vertex. And because it's vertical, then p is positive. We're going to be opening up. So we're going to go 1 up for the focus, and we're going to go 1 down for the directrix line. And lastly, the focal width is 4. Absolute value of that is +4. So we're going to go half of that on either side so that we can draw our parabola opening up. Okay, next we're going to talk about circles. The form for a circle, I'll just remind you, the center again is HK, like a vertex was for parabolas. The formula in general for a circle, is x minus h squared plus y minus k squared equals r squared. So if we're given the center and the radius, we're just going to be plugging in. We have x minus 2 quantity squared plus y plus 3 quantity squared, and r squared, 3 squared is 9, so that's how we're going to leave it. The origin, if I have x minus 0 quantity squared, well, x minus 0 is just x, so it's really just x squared plus y squared, because y minus 0 squared is still y squared. And then 2 square root of 5 squared. Well, that's either 2 square root of 5 times 2 square root of 5 when I'm squaring it, which would be 4 square root of 25, which is 4 times 5, or 20. Or I can type it into the calculator with a parentheses and the squared on the final outside part of it. So as long as I type it correctly, then the calculator will work for me. But if I didn't put the parentheses around the whole thing, the whole 2 square root of 5, then it won't give me the correct answer. The next part is going to talk about ellipses. So let's be reminded that for an ellipse, we look at the denominator and see where the bigger denominator is located to determine vertical or horizontal. So let me give you a quick reminder of those. When it's vertical, we have x minus h squared and y minus k squared, both for the numerators. But when it's vertical, the a squared is under the y portion and the b squared is under the x. So the other would be when it's horizontal, we have still the x minus h squared and y minus k squared for our numerators, but being horizontal, the a squared is under the x. Whoops. The b squared is under the y. So first off, if the center is at -1, 2, and the horizontal major axis, so we know it's horizontal, is 10. So that means that if I go a total of 10, I need to go 5 on either side. And that also tells me that A would be 5, which is half of the 10, because from the center to one vertex, that is the A amount. They tell us C, so I just rewrote that. And we do need to know our center. That's our H and K for our equation. But I need to know what B is. Well, we have a C squared equation for an ellipse that is C squared equals A squared minus B squared.
So when I plug in the values and solve for b squared, just doing this quick, when I get a positive b squared is a positive 16. Remember that b would be a 4, but remember that the b squared is what goes in the answer. So we're going to write our answer. That's a fraction plus fraction equals 1. The center is going to be x plus 1 quantity squared, y minus 2 quantity squared for my h and k. Because it's horizontal, then our a squared is going to be under the x, and the b squared is going to be under the y. This one has a center at 0, 3, vertices at 0, 8, and 0, negative 2. So first of all, this means it is vertical, and the a value, won't go into the vertices, is a 5. And they gave us the foci at 0, 5. I'll label V for vertices and F for foci, and 0, 1. And that's focus. So from the center to a focus is the C value, which is 2. And I need to find, using our C squared equation, and that is 4 equals 25 minus b squared. Subtracting 25, I get negative 21 equals a negative b squared. So b squared is a positive 21. And again, that's what I need to put in my equation. Because it's vertical, we have the a squared being under the y, but we're going to start with our center, and I'm going to circle that. So x minus 0, which I don't need to put the parentheses then. It'll be x squared, y minus 3 quantity squared. And again, vertical, because the a squared is going to go under the y, b squared under the x. Moving along. Here's, we're going to graph these ellipses. So this one, because the denominator, the bigger denominator is a squared, and that means that this one under here is going to be horizontal. And the center, I just put a C and put the coordinate, is HK. So I'm going to take the H is with the X and K is with the Y, but the opposite sign. So our center is at negative 2, 3. And the A, because the bigger denominator is a squared, then A is 6, and B will be 4. So that means I'm going to go horizontally the A amount, both ways, and go vertically the B amount, and then I can graph my ellipse. The next one, because the a squared bigger denominator is under the y, that means it's vertical. Because the numerator has nothing subtracted from x or the y, that means our center is the origin, 0, 0. And a squared being the bigger denominator means a is 5 and b is 3. So we're going to go vertically the 5 and horizontally the 3. And then we draw our vertical ellipse. The hyperbola. Okay, the hyperbola, we have to look specifically at the types of hyperbola that we know for horizontal and vertical. So I'll just make this as a note over here. So horizontal hyperbola is when we have the x minus h squared, y minus k squared. X is first on the top. This one we look at the numerator to see which is first, x or y. The a squared and b squared are always in the same location for the two types. So vertical is going to be when the y is first on the top. The a squared always is the bottom left, b squared is always the bottom right. So there's just a general rule for hyperbola. The 6a, we have the center given At 1, 4, it's a vertical transverse axis, which is 8. So I know it's vertical. I know my center, which is HK, and I'll need that for my answer. The vertical transverse axis, that's the total, so that means that A would be half of that, which is 4, and they tell us C. Well, we need to know, use our C-squared equation for a hyperbola, which is C squared equals A squared plus B squared. And so plugging in those values, we will be able to solve for B squared, that we can put that in our answer. So we get 20 for B squared. And I have the fraction minus fraction equals 1. Because it's vertical, that means the y comes first. We take the y part of our vertex with it. And then the x part of our, I'm sorry, I called it vertex, I meant center, excuse me. And then for the denominator, A squared is always in the bottom left, and B squared is the bottom right. The next one, we have our center, which is HK, which will go into our equation. If our vertices are at -5, 0, and at 1, 0, if I make a quick little sketch of that, then I can see that from the center to one vertex is going to be 3. So I know that also that it's horizontal because of the direction it is, and that we just said A was 3. And the foci are at -8, 0, and at 4, 0. So from the center to one focus point, that is the C value, which will be a 6 here. And then if we use our C-squared equation, C squared equals A squared plus B squared, and I plug into that, and subtracting the 9, we get B squared to be 27. So we're ready to write our equation. Because it's horizontal, the x comes first. We take the x part of our vertex, excuse me, I keep saying that, excuse me, the center. And then y minus 0 would be a y squared. A squared is always the bottom left, which here is a 9, and B squared is under the y, which is 7 for that. The next one's to graph the hyperbola. We have first, because the x is first, we know that is horizontal. We know our center point coordinate would be HK, which H is with the x, K is with the y. And then the A squared is 16, so A is 4 and B is 5, because A squared is always bottom left, remember. We have 2, -1, and sorry, 2, -1 is our center. Because it's horizontal, we have to go horizontally the A amount and vertically the B amount. And that allows us to draw the rectangle for the hyperbola. Remember, the next thing we do is we draw the asymptotes that go through the center and through the opposite corners of the rectangle. Because it's horizontal, it's going to go through the vertex and approach the asymptotes, opening left and right for the branches. And that's our hyperbola. The next one, because it's y squared, it means it is vertical. Y squared first. The center will be HK. H is with the x and K is with the y. A squared is 9 because it's the bottom left, so A is 3 and B is 6. So we're going to plot -3, 0, and we're going to go vertically the A amount both ways and horizontally the B amount both ways. And that allows us to draw our rectangle. That we can draw our diagonals that are the asymptotes. And to draw the vertical hyperbola, we're going to draw through the vertices and approaching the asymptotes on each side to have an up and down opening branch.
Sorry, I was just making a video for Algebra 2. Can I finish real quick? I'm trying to, I'm on the last couple of problems, so they're standing out there and I can hear them like, is she making a video? Because usually it's for pre-cal and I'm like, no, it's for Algebra 2. Okay, inverses.